Get parallel and perpendicular lines, 7.4. So parallel lines, the word parallel just means lines are running next to each other, kind of like that. And they go on forever and they'll never touch. Perpendicular lines is where there's a point where they cross at 90-degree angles, right? So 90 degrees, 90 degrees, 90 degrees. Okay. So when does this occur? When does perpendicular lines or parallel lines occur in an equation? How can you recognize them? So before we just jump into the little definition here, we'll just do a little investigation. So it says to graph each of the lines. We'll graph two. Once you get two, you'll get the idea. You don't have to graph all four. So we'll graph line one. So line one, and it might be helpful if you have a couple different colors, but we'll just use one because I only have one right now. So the y-intercept, this is, again, you should recognize this is a slope-intercept form, right? Y equals mx plus b. This is the y-intercept. So equation 1, -1 right here. 0 is where it lies on the graph. And their slope is 2, so and it's positive, so it's up 2, rise, and over run, which is 1, because, again, this is 2 over 1. And let's do one more, 1, 2, over 1. Okay, and then get your ruler, if you have a ruler. You should have a ruler there. Otherwise, use a straight edge. All right, and this line go like that. And I'm just going to label it 1. All right, you should write the equation, so maybe I'll write it 2. So y equals 2x minus 1. Okay. All right, so let's do another line here. We'll do one a little bit further. We'll do line 3. So y equals 2x minus 7. So let's go to the -7, the y-intercept. So 1, 2, sorry, right here. 1, 2, 3, 4, 5, 6, 7, right here. And the slope is also 2. So up to 1, 2, and over 1. Up to 1, 2, over 1. Okay. And now use straight edge again. Okay. And let's go make sure the line's straight. And this is kind of why you should use rulers so you can kind of see. Okay. But there we go. Okay. Let's label this point 3, which is y equals 2x minus 7. Okay. So what do you notice about these two lines? Okay. These two lines here are parallel. Okay. So when do we get a parallel line from these based on these equations? You can see the similarities. Their y's are different, right? But their slope is the same. So when you have the same slope but different y, you'll get parallel lines. So let's write that. Same slope but different y gives a different y-intercept. So it gives parallel lines. Okay. Now let's look at the definitions to make sure we're okay. Parallel lines have the same slope but different y-intercepts. Note if the lines had the same slope and the same y-intercept, they would be coincide or be the same line. So that makes sense. If they had the same y, right? Imagine if this was the same as the y here, -1, then it would just be the same line. They'd be on top of each other. Horizontal lines are parallel if they have different y-intercepts, and vertical lines are parallel if they have different x-intercepts. Okay. So they need to have different y's and x. If their y's and x's were same for horizontal and parallel, again they would be the same line, right? Because their x-intercepts and y-intercepts is the only points that they're going along because they're horizontal and vertical. Okay. Let's do another investigation. So you can see the spoiler ahead. We're going to look at perpendicular lines. So we'll just do two of them here. So y equals -4x plus 1. So again, go to plus 1 and to a point. And then the slope here is 4. So you go rise 4. 1, 2, 3, 4, and over 1. Let's do one more. 1, 2, 3, 4, over 1. Okay. And let's do a line here. There we go. Okay, and let's do another one. So this is line 1, y equals 4x plus 1. Okay, let's do line 2. Okay. Actually, let's do, these ones are like pairs. Okay. Oh, so we got to do this one here. So y equals negative 1/4 x plus 1. So again, we're on the plus 1 section. And now we're going to go, the rise is actually negative, so it's going to go downwards, right? So down 1, right? And over 4. 1, 2, 3, 4. Down 1, over 4. 1, 2, 3, 4. Okay, so now we're actually going this way. Okay, there we go. And now we can label this line as y equals negative 1/4 x plus 1. Okay, so in order not to be too messy, I'm just going to do these two, otherwise you're going to have like 4 other lines here. So what do you notice here? You notice that we have 90-degree angles here. These two lines are perpendicular. And you have to believe me, if you graph these ones, these would be perpendicular and perpendicular. Okay, so why are they perpendicular? So it looks like they're, what kind of pattern do you see? It looks like their y's are different, right? And we'll talk about that in a bit. But how are their slopes related? So if you take a second, you kind of see the pattern here. So here's 4, here's negative 1/4, here's negative 2, here's 1/2. So their base, the slope is just the negative reciprocal. And reciprocal just means the flip. You float the fractions around. So negative reciprocal is you flip it. So this is 4/1. So instead of 4/1, we get 1/4. And it's negative, so negative 1/4. Negative 2/1. You flip it, it's going to be positive 1/2. Okay. And again, 3/5. You flip it around, 5/3 and negative, so negative 5/3. So let me just move this down actually. There we go. What do you notice? Okay. We notice that perpendicular lines have negative reciprocals. Okay, so let's look at the definition. Okay. Perpendicular lines have slopes that are negative reciprocals. Their y-intercepts may be the same or may be different. So the y's don't really matter here in this case. Okay, why is that? If they had the same y, they would just cross at that point. They wouldn't be the same line because they have negative slopes. Whereas the parallel lines, if they're parallel, they have the same slope and the same y, then they'd be the same line. Okay. Vertical lines are perpendicular to horizontal lines. Therefore, a slope of 0 is perpendicular to an undefined slope. Okay. So for a line, well, we'll practice this a few times. So for a line with each slope, state the slope of a line parallel to it and the slope of a line perpendicular to it. So now all they're telling us is slope. So we need to tell what would be a parallel line, with what slope would a parallel line have, and what slope would a perpendicular line have. So I'm just going to type para to be short, perp for perpendicular. Okay. Okay, para perpendicular. Para perpendicular, finally paraline and perpendicular. Okay, so what do you know about parallel lines? They have the same slope, so it's just going to be 3. Okay. What about perpendicular? Negative flip. So 3/1 is going to be 1/3 and negative. Easy, right? Parallel lines, same slope. Perpendicular lines, negative flip. So this one is going to be positive 1/4. Okay. Here we got, again, parallel lines, same slope, perpendicular, negative flip, which is going to be negative 3. And for the fraction, it's going to be, for parallel lines, same slope, and the perpendicular is going to be a negative flip. This is over 1, so you can just do 1 over 0.4 negative. And it's okay, just leave it as that, because that's how they left it, as decimal in the question. Okay, so next page. Okay, so let's move this up. Okay, example 2, state the slopes of the lines are parallel to and the lines are perpendicular to each linear equation. So this is the same thing that we just did, but now they're giving us the whole equation. It's in slope-intercept form, so you know that y equals mx plus b right here. Okay, so what we can do here is, right now you can see this parallel line, the slope is going to be just the same, which is going to be 2, right? So what's the best way to do parallel lines? I think they're just asking for slope. So slope is going to be 2. And perpendicular line is going to be the negative flip of 2, so negative 1/2. Okay, so here we got general form. So there's a few different ways you can do this. I would just convert it to slope-intercept form. Then you can see the slope pretty quickly. So let's move stuff over, and I'll try to do some of this in my head, but I'll do a little bit. So negative 4y, move everything else to one side. It's going to be equal to negative 3x plus 3. Take away the negatives, right? Cross them out and divide it by 4. So it's going to be y equals 3, 3 over 4 x minus 3 over 4. Okay. Now you can see the slope is 3 over 4. So parallel line equals the same slope. And then perpendicular line is a negative flip, which is negative 4 over 3. Okay. Okay, let's do this one. Maybe already a little bit smaller. Okay, here it's already in slope-intercept form, so just simply go parallel line equals negative 1 over 4, and perpendicular line is equal to the negative flip, which is just going to be 4, right? Bring it around. So again, this is a general form. We're going to switch it to slope-intercept form. So 5y equals negative 2x plus 1. Divide by 5. So y equals negative 2x over 5 plus 1 over 5. And then parallel lines equals, parallel line is going to be the same slope. And perpendicular is going to be the negative flip, which is going to be 5 over 2 in this case. Okay, hopefully that kind of made sense. Let's do example 3. So for each pair of slopes, what is the value of k if the lines are parallel? What is the value of k if the lines are perpendicular? So it looks like they're giving us two slopes of two different lines. They're saying, what does k have to be in order for this to be parallel, and what does the k have to be if these two lines are perpendicular? Okay, yeah, so slope 1, slope 2. So what does k have to be if it's parallel? Let's just type parallel. So for parallel lines, these two have to be the same, right? So k over 3 has to equal 4 because the slopes need to be the same. So how do you make that the same? So how does this equal 4? So it's going to be, well, we could just write it as a, I'm just worried about, we're going to run out of room. So k over 3 equals 4 over 1, right? So we got this ratio here. So to do this, you're just going to do, I just do cross multiply and divide. So when you have a ratio of 1 unknown and 3 knowns, you can just multiply across the knowns. So 3 times 4 is 12. 12 divided 1 is just 12. So k is 12. Okay. What if it's perpendicular? Okay. Remember, perpendicular, k over 3. One slope has to be the negative reciprocal of the other. So you can set it up as a fraction again. K over 3. This time it's going to equal, instead of 4, 1, negative 1 over 4. So again, negative 1 times 3 is negative 3. Negative 3 divided by 4 is, just leave it at that, negative 3 over 4. Okay, so let's try that again. This one's a little bit easier. So K to be, how's for parallel? K is going to equal simply 1, right? Because they're the same, 1 and 1. And perpendicular, K is going to be the negative reciprocal of 1, which is going to be negative 1. Okay. Here we set it up the same way. Okay. So for parallel lines, 2 over 1 is going to equal 5 over K. So here we go, running out of room again. So K equals cross multiply. So again, we set up the ratio, cross multiply. 5 times 1 is 5, divided by 2 is 5 over 2. Right? And then perpendicular, we set up the ratio, but change 1 to negative flip. So negative 1 over 2 equals 5 over K. 5 times 2 is 10. 10 divided by negative 1 is going to be negative 10. Okay. Okay, the last one here. So parallel line, 3 over 5 is equal to K over 15. So K is going to be 15 times 3 is 15, 30, 45. 45 divided by 5 is 9. Okay. What about perpendicular? Negative flip of 1, so negative 5 over 3 equals K over 15. 15 times 5, okay. So 15 times 5 is going to be 75, right? Negative 75. And negative 75 divided by 3 is negative 25, I believe. Yeah. Okay, and then that's that. So there's practice if you want to try this out. Otherwise, you can just do the textbook work. And I'll need to scan this, or you guys can write your own notes as well. Okay, so maybe I'll scan this copy and put it up as well.